Hi, my name is Kevin Cohen. This is my coronavirus confinement haircut. This is my coronavirus confinement beard. And this video is a tutorial on how to review the conclusion section of a data science research paper. And I'll be focusing on machine learning and natural language processing. This tutorial was prepared with my colleagues Karen Faure, Aurélie Neveol, and Margot Miskas. So let's start by making clear what it is we're going to be talking about here. So we're talking about conclusion section, and at the same time, we're going to talk about conclusions. Well, when I talk about a conclusion section, I mean the last section of a paper. Sometimes it's called the conclusion section, sometimes it's called the discussion and conclusion section, and it typically has three parts, which you see on the left-hand side of your slide. So one of those parts is a review of the work that's been presented in the paper. What was the question? What were the methods used? What were the materials, the findings, and what those findings mean with respect to the question that was being asked? There's often a section on future work to be done, on limitations of the present work, on remaining open questions, something like that. And then there is a conclusion. What do I mean by a conclusion? It's a very ambiguous word in English. One meaning of it is the last part of something, and this is the last part of the paper. But the meanings that are more relevant here are a reasoned judgment. That would be a judgment about what the results mean with respect to the question being asked by the paper, or the necessary consequence of two or more propositions that are taken as premises. And so in that case, what that would mean here is that we have the premises that a question exists in the paper, that the materials and methods are appropriate to answering that question, and that the results do give you some kind of an answer, and then the conclusion would be what the consequence is of those premises. To find the conclusion in this sense in a paper, look for words like "we have shown that" or "we report," something like that. And the reason we're talking about conclusion sections at all in the context of a tutorial on reviewing is that conclusion sections are a nearly universal section of papers in our fields. It's quite unusual, actually, to read a paper in any area of data science, whether that be natural language processing or machine learning, what have you, that doesn't include a conclusion section. So here's a little exercise for how to answer the major question, the major question in evaluating the conclusion of a paper is this. Is the conclusion in the sense of that statement that is implied by the premises or that follows necessarily from the premises, is it supported by the methodology of the paper and then the outcomes of the experiments that were done? You might be wondering right now, that's a huge question, right? In some ways, everything we do to learn about how to be scientists is about learning to pose that question in our own papers and to answer that question when reading other papers. Can we do that without being experts in the field? Let's look at an example. So here's an exercise, and we're going to ask a simple yes or no question. Do the methodology and the outcomes that are reported here support the conclusion? So on the left-hand side of your slide, you'll see the methodology and outcome reported in a paper. So the paper's methodology is to compare a machine learning classifier called a support vector machine with one kind of feature called a bag of words. And if you don't know what any of this means, that's going to be relevant. You'll see. So the paper compares that with an SVM classifier that has something called glove word embeddings and a bag of words as features. So case number 1 is one set of features called a bag of words. Case number 2 is a classifier with 2 sets of features, one of which is the bag of words and one of which is glove word embeddings. And then the outcome is that the SVM classifier with glove word embeddings as features outperforms the SVM classifier with only a bag of words as features. And then the conclusion of the paper is that deep learning is the best approach to classification tasks. So take a minute to think about it, pause your video while you do that, and I will go get a cup of coffee. So you've thought about this. What's the answer? It's probably fairly clear to you that no, in fact, the methodology and the outcome don't support the conclusion. How do we know that, even if we're not experts in the field? Because the paper compared 2 feature sets. One of those feature sets was partially produced by a neural network. That is the glove features. But the fact that this part of the feature set in that second condition was produced by a neural network, that doesn't tell us anything about neural networks per se. So given that the conclusion of the paper is that deep learning is the best approach to classification tasks, and that the paper didn't actually evaluate deep learning itself, says to us, no, the methodology and the outcomes don't actually support the conclusion. If you are an expert in the field, you might be thinking, well, it's had glove word embeddings. Well, and glove is a neural network technique, but the features are word embeddings. Where those came from, it's not relevant to what actually happened in the outcomes of the experiment, one way or the other. You could have gotten those word embeddings from word2vec. You could have calculated them by hand, right? That doesn't have anything to do with the actual experimental setup. And therefore, concluding from this that deep learning is the best approach to classification tasks, that's not valid. If you have questions about this, or if you just disagree with me, we'll cover them during the discussion section. Please bring your questions or disagreements ready to talk about them. So what do you do with your evaluation of the conclusion section? Obviously, you're going to talk about it in your written comments to the authors, but how do you score it? Well, it's usually your evaluation for this is usually scored as part of the acceptance or rejection recommendation. I say that because typically there isn't a specific review criterion like, do the methods and the outcome support the conclusion? When you don't have that specific review criterion, it's essentially subsumed by your overall acceptance recommendation. So if indeed the methods and the outcomes support the conclusion, you might recommend acceptance of that paper, assuming that it's significant and innovative and so on and so forth. If the methods and the outcome don't support the conclusion, you're probably going to recommend rejection for that paper. So we've talked a little bit about what the typical parts are of a conclusion section or a discussion and conclusion section. I'm going to repeat those here just for your reference. It's a little bit expanded from the way I talked about them in the previous slide. Just know that this is what you look for in a good conclusion section. So let's look at another exercise here. And again, we're going to ask a simple yes or no question. Do the methodology and the outcomes support the conclusion? So let's pause the video for a second. I will go clean up some cat vomit. And when you have an answer to the question, start the video again. Okay, cat vomit cleaned up. So let's talk about this now. So we have a specific pipeline that's applied to a publicly available data set. A single value is reported. That value is compared to previously reported scores, and the value is higher than the previously reported scores. Experimental details aren't really given, and there's no code available for this pipeline. The conclusion then is we have state-of-the-art performance on this data set. If you are far enough along in your career to be watching a video about reviewing conclusion section, you have probably read some form of this paper 1,000 times. Does the methodology and the outcome, do they support the conclusion? No. Why do I say that? Because the paper provides about as much detail as an advertisement for a product. Under-described methods, unavailable code, mean that the paper does not actually describe the methods. You have to ask then, is the outcome even valid in the scientific sense? Does it answer the question that the paper is at least implicitly asking? Indeed, if you don't know what the methods are and you don't know what the people did, you have some questions about the actual outcomes of the reported values, then a conclusion that we have state-of-the-art performance, it's not supported by the paper itself. Could be true. We don't know. If we don't know, we're probably not gonna accept that paper, right? So let me give you an extended exercise now. And again, we're gonna ask that simple question. Do the methods and the outcomes support the conclusion or don't they? And what I'm gonna talk about here, rather than an abstract paper, is some work that I actually did myself pretty recently. So my task here is a completely novel document classification target. So we've all seen 1,000 document classification papers. This was, I was looking for a kind of paper that no one has ever tried to classify before. My data, I had 100 positive instances and I had 100 controls or negative instances. My methodology was quite straightforward. I had a bag of words and 3 classifiers, and I got a result of 0.85 F measure. 0.85 F measure, your first attempt with a bag of words, very simple feature set, wonderful, right? Does that support the conclusion that I have state-of-the-art performance on this task? Well, I'm the first one to ever do the task, right? Necessarily, any performance that I get is going to be the state-of-the-art, right? And my state-of-the-art was pretty good for a first attempt. 0.85, that's pretty publishable. Actually, though, the methodology here didn't actually do the task that was intended. Let me show you what I know. So I was trying to do a completely novel document classification task. And I told you about the methods. I told you a little bit about the data, but not everything. So my 100 positive instances were extracted from PDFs. The 100 controls were text that was taken out of PubMed Central XML. Now, it happens to be the case that if your data source is what's called PubMed Central XML, it's very clean. In contrast, if you extracted your data from PDFs, there's usually some noise in it. And indeed, what I turned out to be training on when I got that wonderful F measure with bag of words, it was artifacts that came out of the PDF extraction. So you got a PDF, you pull out some text from it, you get some artifact from that. And the signal that I was training on was actually the artifacts of the PDF extraction. So this is a classic case of what's called the confound. Confound means that there are two possible explanations for the outcome, and you just can't tell which of the two is the real one. Did I really do my document classification task? Did I just train on the PDF extraction errors? I don't know. I don't have a way to tell them apart. If I don't have a way to explain the outcome of the experiment, I can't conclude anything from it. Now, the reason I bring this up is that natural language processing research is rife with confounds. Rife with means that they're everywhere, including hidden away where you don't see them. It's like cockroaches in the kitchen of that apartment I had in college. Let me give you some examples of ways you can see that. So in the upper left-hand corner of your screen, you're seeing a section of a paper by Trishnig et al. On tokenization. And what they showed in that paper was that tokenization can actually have a bigger effect on system performance than the choice of an algorithm. Now, if you're writing a paper, if you're reviewing a paper on an algorithm and tokenization could explain the results as easy as the choice of algorithm, then you have and you can't tell the difference, you have a confound. It's not a paper you're going to accept. It's a wonderful paper. I think one of the most important of the past decade or so. In the lower left-hand corner of your slide, you see a paper with a table that shows that the effect of balance on your performance can be quite large. That's a big enough difference in performance to make the difference between beating the state of the art and not. And again, if you don't know if the cause of your performance difference is the system that you built or the balance that you used on the data, it's not a paper that you're going to accept. Figure in the lower right-hand corner showing learning curves, comparing 5 systems where you see that with a small amount of data, there's a particular ordering from top to bottom of system performance, and that with more data, the ordering completely reverses. Again, this is a situation where somebody might be writing a paper about this system, but in truth, you don't know whether the ordering of the system performances is due to differences in the algorithms or just to the amount of training data. And the ordering might be completely different with another order. Again, another kind of confound where you don't know whether the cause of the performance differences is the algorithm or the amount of training data that was used in those particular experiments. And that's from a paper by Banco and Brill. It was the first natural language processing paper that rocked my world, and I strongly suggest that you read it. So we've talked a lot about a number of fairly specific contexts, and I want to give you some pointers to things that you could read to learn more about them. So when we talk about that question of whether or not the conclusion actually is relevant to the methodology that was answering a question, that is called spin when they don't match up. I'm giving you pointers to a number of papers here, most of them by Anna Koroleva and Patrick Darubek, on the question of spin and how to detect it with NLP. And then the last paper on there is a question about reviewers and how good they do or don't do at recognizing spin in papers. Here is some work on confounds in natural language processing, and some work on the question of what do results actually mean? And you'll see quite a few authors who have looked at this question in machine learning in general and in natural language processing in particular. So as we end this tutorial, I would like to remind you that this material was co-written with my colleagues Karen Faure, Margot Miskis, and Aurélie Neveol. And I'd like to wrap up with one final exercise for you. Here it is. Describe a paper such that the methodology and the outcomes support the conclusion. Now, this is hard. We all spend our entire careers trying to figure out how to write that paper. But it's worth doing. As the great sage Hillel put it, all the rest is commentary. Now go and study. Thanks for your attention and have a good pandemic.